Have you ever considered what happens at the end of everything? The final curtain call for the cosmos? A thought that has plagued the minds of many over the centuries. The concept of the universe's death is as daunting as it is inevitable. This is not a question of if, but when. The universe, in all its vastness and mystery, is not immortal. Its life, like everything else, has an expiration date. Scientists, philosophers, and thinkers have grappled with this ultimate question for millennia, seeking answers in the stars, the laws of physics, and the recesses of human imagination. Theories abound, each more fascinating and complex than the last. Some suggest a slow and gradual cooling, others a violent and immediate end. The truth, as always, probably lies somewhere in between. So what does the end of the universe look like? Let's dive in. To understand the end, we first need to comprehend the timeline of the cosmos. Our cosmic journey began nearly 14 billion years ago with a colossal event known as the Big Bang. This wasn't an explosion in space, but rather an explosion of space. From a point of singularity, where all matter and energy were concentrated, the universe began expanding at an incredible speed. It was a hot, dense state of energy that gradually cooled down, setting the stage for the formation of the first atoms. About a few 100,000 years after the Big Bang, these atoms coalesced to form the first molecules. And as the universe continued to expand and cool, these molecules started to clump together under gravity, forming the first stars and galaxies. These celestial bodies lit up the universe, marking the end of the so-called cosmic dark ages. Fast forward to 9 billion years after the Big Bang, and our own solar system was born. From a cloud of gas and dust, our sun ignited and the planets, including Earth, formed. It was on this tiny blue dot that life as we know it began and evolved. Now we find ourselves in the present day, approximately 14 billion years after the Big Bang. Our universe is still expanding, with galaxies moving away from each other. Stars continue to be born and die in a cycle of cosmic life and death. But like everything else, our universe too has a lifespan. The stars won't shine forever, the galaxies will stop forming. The universe as we know it will undergo dramatic changes leading to its eventual death. But what does the end of the universe look like? What events will unfold leading to this cosmic finale? Now that we have a grasp on the universe's timeline, we can delve into its impending doom. One of the most accepted theories about the universe's end is known as the Big Freeze. This chilling theory suggests that the universe, much like a balloon being filled with air, will continue to expand, stretching out into infinity. As it expands, the universe will cool, becoming less and less hospitable to life as we know it. Imagine the universe as a pot of water on a stove. The heat, representing the energy of the universe, causes the water, or the galaxies and stars within the universe, to boil and bubble. But if you turn off the heat, the water slowly cools down, the bubbling stops, and eventually, it all becomes still. This is the essence of the Big Freeze theory. As the universe expands, distances between galaxies will increase, causing them to move apart. With time, these galaxies will become isolated, the light from their stars unable to reach one another. The universe, once a vibrant and bustling place, will become a dark and lonely void. Stars, the powerhouses of the universe, will exhaust their fuel and burn out. Without the energy from these stars, new ones can't form. The universe will become a graveyard of dead stars, dark planets, and black holes. The Big Freeze theory also predicts the eventual death of black holes. Even these monstrous entities, with their immense gravitational pull, can't escape the relentless march of time. After an unimaginable period, black holes will evaporate through a process known as Hawking radiation, named after the legendary physicist Stephen Hawking. Once the last black hole has evaporated, the universe will reach absolute zero, the lowest possible temperature where all atomic motion ceases. This will be the final state of the universe, a cold, dark, and lifeless place. So the universe might turn into a cold, dark, and lifeless place. But that's not the only possibility. What if it ends with a bang? Remember when we talked about the universe's expansion? What if it doesn't last forever? Or what if it accelerates uncontrollably? Let's dive into the first scenario, the Big Crunch theory. Picture this: the universe's expansion, which has been ongoing for billions of years, starts to slow down. Gradually, the galaxies stop moving away from each other. It's as if time is running in reverse. And then, the unthinkable happens. The expansion doesn't just stop, it reverses. Everything from galaxies to the tiniest particles starts rushing back towards a central point. This is the Big Crunch, the exact opposite of the Big Bang. A universe that once exploded into existence from a singularity now collapses back into one. The cosmos, once filled with light and life, becomes a single point of infinite density, an end that is as dramatic as the beginning. But what if the universe's expansion doesn't slow down? What if, instead, it speeds up? This brings us to the second scenario, the Big Rip theory. Imagine a universe where the expansion is not just continuing, but accelerating. The galaxies are not just moving away from each other, they are being ripped apart. The stars, the planets, even the atoms that make up everything we know, are torn apart by the force of the expansion. The universe becomes a vast, empty void, with no trace of the galaxies, stars, or life it once held. In this scenario, the universe doesn't collapse into a singularity. Instead, it stretches itself into oblivion until there is nothing left but the echoes of what once was. A universe that began with a bang ends with a rip. Whether it's a crunch, a rip, or a freeze, the end of the universe seems bleak. But what happens after that? Once the universe meets its end, what could possibly follow? It's a question that has sparked the curiosity of scientists and philosophers alike, leaving us with a realm of fascinating theories to ponder. Let's start with the idea of the multiverse, a concept that has been drawing increasing attention. The multiverse theory suggests that our universe is but one of countless others, each with its own unique laws of physics, and possibly its own unique timeline. So while our universe might be heading towards its end, there could be countless others just beginning, or in the full swing of their cosmic dance. This concept is as humbling as it is mind-boggling, isn't it? Then, we have the cyclic universe theory. This theory proposes that the universe doesn't just have one beginning and one end. Instead, it's a cyclical process of birth, death, and rebirth. Imagine, if you will, the universe as an immortal phoenix, rising from its own ashes time and time again. Each cycle could last trillions upon trillions of years, with each death leading to a new Big Bang, a new universe, a new beginning. Of course, these are but theories, ideas that we're still trying to comprehend and prove. The truth is, we may never know for certain what lies beyond the end of our universe. But isn't that uncertainty part of the beauty of it all? The mystery, the potential for limitless possibilities, the sense of wonder that comes with exploring the unknown. At the end of the day, the death of the universe doesn't have to be viewed as a definitive end. Instead, we could see it as a transition, a metamorphosis of sorts. Just as a caterpillar transforms into a butterfly, our universe might transform into something entirely new, something we can't even begin to imagine with our current understanding of physics and reality. The death of the universe might not be the absolute end, but rather a transition into something new. This is the beauty and mystery of the cosmos, and it's why we continue to explore and learn, always reaching for the stars. So, we've taken a journey from the birth of the universe to its possible demise and beyond. We've delved into the depths of cosmic time, navigating the mysteries of what might lie ahead. We've explored the chilling prospect of the Big Freeze, where the universe slowly exhausts its energy, and the stars flicker out one by one. We've also examined the explosive possibilities of the Big Crunch and the Big Rip, where the universe could either implode in on itself or be ripped apart by its own expanding energy. We've even ventured into the captivating ideas of a multiverse, where our universe is but one of countless others, or a cyclic universe, where death is just a prelude to another cosmic birth. The universe's end is a topic filled with mystery and speculation, but one thing is certain: the cosmos has a lot more stories to tell before its final chapter.